Hello, welcome back, my dear children, students, guys and girls. That's what you like and love, right? I'm Professor Vikram over here, and today we are going to do something new, something different. Sorry, the topic is already there on the board, so you know what we are going to do. Okay, it's language of chemistry. So now you can think, or you must be thinking, basically, how come language term comes in chemistry? Definitely it will come. Come on. Language comes in English, language comes in Spanish, French, any other language, you know. Language means the way we express that particular subject. I mean, the terminologies, the definitions, the way we explain that entire subject is the language of that subject. Okay, so we know that in the past, right from Stone Age till now, man has been doing a lot of research and discoveries have happened in the past. So many elements, compounds have been discovered. Okay, and what made us? It's basically, we say necessity is the mother of all inventions, right? So it's the necessity which makes us do a lot of research work, and based on that only we discovered so many different things that it was very much important to bifurcate all of them into different subjects, or you can say languages, or you can say different sciences. For example, like physics, light, sound, travel and energy, everything comes in physics, right? And when we talk about biology, it's all about life sciences, living organisms, non-living organisms, their way of operations, everything comes in bio. And when it comes to chemistry, what does chemistry deal with? Can you tell me? Chemistry deals with matter, nature, the structure, what is there all around us. That is what chemistry is dealing with. What is matter? Matter is all around us, right? It's there within me. I am a matter. You are a matter. Everything around us is matter. What is matter? Matter is nothing but it occupies space and has mass. That is called as matter. And matter is made up of elements. So we know that matter is made up of elements. Okay, our physicists, chemists have been great enough to do all this thing for us, and we are lucky that we are there in the 21st century to understand and know about matter and elements, right? So what are elements? Elements are the purest, simplest form of matter. Elements are pure and simplest form of matter. They are the purest and simplest form of matter which cannot be decomposed further. Cannot, I repeat, it cannot be decomposed. Now what do you mean by decomposed? Cannot be decomposed means elements cannot be broken further because they are in their pure and simplest form. And what are elements made up of? Elements are made up of atoms. An atom is the simplest, smallest, indivisible particle of an element, right? So element is in turn made up of atoms. So I could say that when one or more than one atom combine together, they form an element, right? An atom is indivisible in nature. That was earlier taught. Okay, so we are starting with chemistry language, so we are talking about atoms and its nature. Okay, so this is the smallest particle of an element. This is the smallest particle of an element. Now, the number of atoms which are present in an element is called as its atomicity. The number of atoms which are present in an element is called its atomicity. So from the atom, we get the term atomicity. What do we get the term? Atomicity. It is nothing but number of atoms in an element. It is nothing but number of atoms in an element. So say for example, if an element has only one atom, single atom, what will be that element called as? That element will be called as monoatomic
molecule or monoatomic element. So when I say the term monoatomic, that means it contains one atom, or in other words, I can say that the atomicity of such molecule is 1. What are the examples of monoatomic elements? We'll come to that soon. So atomicity, the very first classification is monoatomic molecules. Okay. The second classification in this comes to be, come on, you know very well, what can it be? When one atom, it's monoatomic, two atoms, it will be called as diatomic, right? You're correct. So we have diatomic molecules, which means the element contains two atoms in it, and there the atomicity will be 2. We will again see what elements or examples fall under diatomic. After diatomic, then we have the third classification as triatomic molecules. Triatomic molecules means the elements that contain 3 atoms. So therefore, the atomicity of such elements is going to be 3, right? They are the triatomic molecule. That way, we have many different types of elements. We also have tetraatomic. Now you will say, what do you mean by tetra? Means 4. Definitely. So tetraatomic means which has 4 atoms in it. So its atomicity is going to be 4. And so on. We proceed further. We also have octahedral or octaatomic molecules. So we have octaatomic molecules as well, which has 8 atoms in it. So therefore, I can say that the atomicity of such an element is 8. So now, I hope you all have understood very well what you mean by monoatomic, diatomic, triatomic, tetraatomic and octaatomic molecules. So it's nothing but it has to do with the number of elements, which are present in each element. Coming to the example of monoatomic elements. So what can be the monoatomic molecules? Can you give me the example? Think. You must have seen your periodic table, right? We'll be discussing that, how the elements are arranged in the periodic table. But there are so many elements. Examples? Yes, you are correct. So we have all inert gases, helium, neon, argon, xenon, radon, all of them fall under monoatomic molecules, correct? So I can say helium, neon as an example of monoatomic molecules. Diatomic, I'll have hydrogen, nitrogen, oxygen. These are all diatomic molecules, right? Even you can take, for example, chlorine, Cl2. They cannot exist independently. So they are the combination of 2 atoms that makes an element. Element, the simplest and the purest form of matter. Atomicity 3. What can it be? The very important element which protects us from the UV radiations of the sun. What was it? Yes, you all know very well. That's ozone, right? So O3, ozone, is a triatomic molecule. What about tetraatomic molecule? Can you give me an example? Phosphorus. That's the best example of tetraatomic molecule. And as far as octaatomic is concerned, I would say sulfur. Sulfur molecule is made up of 8 atoms. So sulfur is an octaatomic in nature. So see how we classify matter, which is made up of elements, which are made up of atoms. So atoms got classified into monoatomic, diatomic, triatomic, tetraatomic, octaatomic. So now we know with this classification a very good clarity on what are mono, di, tetra, tri and octaatomic molecules, correct? That is where was the need to define the language of chemistry, because our physicists, our chemists, they discovered so many different elements. So it was very important that when the number of elements discovered came to around 24, 30 elements, so how do we remember these elements?
it's very, very difficult to remember these elements, and that's why we had to think of a different module or a different method altogether to define chemistry, which was called as the language of chemistry.